Hi, everybody. Welcome back. We're live here doing some hardware live streaming as part of Goliath. And today we're going to be going over a new form factor that I've been working on and thinking about. And so I'll give a little bit of history here, and then we'll start digging in. I'm not sure how far we're going to get. I try not to promise how far we're going to get. I don't call it a part 1 or a part 10 or anything like that. That is a learned behavior after the DRAM module, which I was like, I'm sure we could figure this out in one video, 1 hour-long video, shortly. That is not how that worked out, and that's okay. So if you are watching this after the fact, you can always go to our forum. If you're watching this live, doesn't seem like anyone is yet, no problem. You should be able to comment on LinkedIn or YouTube, and I should see it here in the live stream. And yeah, let me know if you have any thoughts. If not, that's okay too. I'm glad to just be here and playing around with hardware as I like to do. My name is Chris Gamble. I'm head of hardware and developer relations at Goliath. If you don't know, Goliath is a online platform for connecting your IoT devices. And so we're going to be looking at some of those today, including the Aludel Elixir and Ostentis. Those are 2 of our open source boards. I guess I could show that article too, but we recently open sourced all of our hardware. All the stuff we're making in the future also is planned to be open source. Usually we don't put it out until it's ready to go and has an actual release. And yeah, this is what I like doing. So let's dig in. So first things first, let's take a look at this thing. So here is a rash of boards and containers. So this is the, let's start here first. So this is the Elixir. This is the Rev B. If you're looking online, you'll see it as Rev C already because I fixed one of the part errors that was wrong on the Rev B. So I don't want anyone to make the same mistake I did if they're building the same thing. These are microbus click headers here. So you can plug in a click board. I guess you can see that here. They plug in like this. They have different lengths. So this is the longest one. And it's really sized for that, right? So it's sized to fit the longest one here. And on the backside, probably we should have started there. This is an Interrupt 9160. That is a cellular part from Nordic Semiconductor. It's got dual core M33s, running Zephyr, a bunch of sensors on here, some power handling, battery handling. We can do up to 40 volts input on this thing as well. Really just thinking about, I need to change some of the diodes on here. It should be able to go up to 48, thinking about like power over Ethernet and similar, but I got to change the diode here. The switcher itself can go up to 60, so that will be a Rev C change as well. ESP32 right now only being used for Wi-Fi locationing. It can also be used if we switch off the cellular modem in Zephyr, we can also make this a Wi-Fi board, which is pretty cool. Extra memory, like I said, power handling, extra GPIOs for programming, things like that. And this is the input for the higher voltage buzzer for making buzzy sounds. And then these are quick headers. These are a 4-pin JST standard from SparkFun and Adafruit. Adafruit calls it Stemma. SparkFun calls it Quick, QWIIC. And basically this is a 4-pin cable that has I2C signals on it. You can buy them off the shelf. Real nice. I happen to have one. Luckily we're recording near my basket of junk. That's what that looks like. And that plugs in here. And we did that because, one, you can buy a bunch of off-the-shelf circuit boards, which is great, but you can also go and plug it into a front panel. Now, this one actually has its header missing, perhaps showing the vulnerability of this type of header. But so basically it plugs in here. And then this is the Aludel Ostentis. This is another of our open source designs here. These are backlit LEDs, touch panels around the corners here. This is an e-paper screen. And it's all controlled with the Raspberry Pi Pico, but the Pico has special firmware on it to display different stuff on the e-paper, to drive the e-paper display, and then to also act as a I2C peripheral device so that when Elixir or really any kind of board talks to it, it shows up as address 0x12, and you can just send really simple frames to it, because most of the time all we're sending to this display is the temperature is 30.42 Celsius, and then it also automatically actually has some detection. Is like if you send a temperature type data, it's also going to add this icon, that sort of thing. Okay, so this is the form factor. So Elixir, Stentus. And really the whole kind of form factor has been based around this style of box. This is actually a utility box from Bud Industries, which is out of my old hometown of Cleveland, Ohio, where I went to school. I loved it there. It's a nice case. I really like the flange on the side here because that means it's not waterproof, so it's not meant to be waterproof. So usually, insulate or protect your electronics if you need a waterproof type of thing there. But the main thing I really like is that you could just kind of mount this to the wall. We then got these custom versions of this box made. I believe this is the CU 1937-MB box here, the utility box, and we carved out the sides here. We basically went through DigiKey, and got a custom made from Bud and said, hey, we want to carve out on all these boxes because we're going to customize based on what type of design in here. And then, so for this one, this is a good example actually, because this has this bump out for the particulate monitor as part of our air quality monitor reference design. And so if you go to projects.goliath.io, which I can share up on the screen here, we have all of these things available. Of course, I should have had these available here. Let me share screen. Share screen. So we have all of these things available here. This one that we were just looking at is the air quality monitor reference design. This is actually the older version that has a cabled version here. I need to update this with new photos. It also has an older version of the Aludel Mini, which is the board that's basically just gluing together some dev boards, right? So it's still got the click headers, but then the wonderful 9160 Feather from Circuit Dojo, that's on the bottom side, and some power handling. But really, this is kind of the forebear to our Aludel board. We put more stuff on it. We kind of codified it into its own design. And yeah, this is how we build reference design. So these are custom pieces of hardware that you could take, you can download the files, you can build them yourself, that sort of thing. So one of the things that comes up out of this is sometimes we don't want to actually have all of the clickboards kind of in the bottom of this kind of deeper well board. And so I started getting curious about this. Go back to my this view here. So I started getting curious about this and said, well, what if we actually had the clickboards either on the outside or, basically some other kind of interface method. And so I went and ordered one of these. This is the baby brother of the CU 1937-MB. This is the 1935, and it's just a narrower board here. And so I ended up needing to make a bit of a well, one thing I decided is that I actually didn't want the clickboards to be outside of here, at least not in its current incarnation. I guess I could have it flush, but the main thing I started thinking was, what if we actually had it so that, let's see, this one, I have another. What if we had it so that this board is not a display board anymore, but it kind of contains all the stuff, right? So it contains interface elements, it contains additional circuitry. So basically, it's kind of like making our own clickboard without using the click form factor, or it's using the click signals that are on the click headers, but making kind of more open format for what we need here. And so that's what we're going to be doing here today. Was basically we're going to take the Aludel shape and color, and maybe even the icon, might leave the icons here. We're going to close up the hole. We're going to remove a whole bunch of the circuitry. We don't need the Pico anymore. We don't need the circuitry for the drive and the e-paper. And instead, we're just going to make a really simple interface board that plugs in to here. And some of this also came from some of the applications we're seeing at Goliath. And so if you imagine, we want to have, so like a smart locker is one that has, we've thought about making a reference design for. It's a project I've made in my past, actually using Goliath. And it's basically just a couple relays. It doesn't really need to have much going on there. So a couple relays, you need an external power source. You're just switching 12 volts on and off, or really, any kind of power on and off. And so what if we just wanted to do that and make a simple, custom, ready to go kind of thing? And so I think that's going to be the first design we make here as well. So it's going to be, today we're going to talk form factor, and we're going to talk about how these things fit together. And then we'll have kind of a basis for building customs in the future. So a relay board, if we wanted to make a high speed custom ADC board, or if we wanted to make kind of a more generic data acquisition board, and so having a bunch of protection circuitry on it. The boards that go on the top of this thing are probably going to be very simple, hopefully very cheap. They're going to plug into the bottom board, and then they're going to just be just another thing into this ecosystem, but have the same elements as well, right? So this doesn't show, like, this is not flush screws. These are not flush screws because this was too small at the time. But these are not flush screws that are super easy to get. And so basically it screws down, and now we have kind of a flat surface to put all of our new circuitry onto. It's still reference hardware. Basically, it's not a product. But if you're ready to put something out in the world and you want to prototype quickly, I think this is a great use case for that sort of thing. The only thing that I am not certain about is if we go back here. So we're specifically designing around the Elixir board here. So one thing we have to think about is we have to have a cutout for this power input here, because that does go above the surface of the board there. Just there we go, like that. So we're definitely gonna have a cutout here. We do not have any kind of cutout in the side for the USB. So the USB would have to be either cut out later, or just we're planning on not using it. But to be honest, with the 9160, with Goliath's logging, with even with using something like this is a tag connect header, and so you could basically turn on J-Link's RTT, so you could basically do logging through here as well. You don't even need the USB here. We have power through the 2-pin JSTPH, which is fits those form factor, the flat pack battery form factors. This one actually fits I think with my box of junk around here, I'd have it ready to go. Can't seem to find a battery on my bench right now. I just saw one. Hear me rustling around here. There are definitely batteries around here, but basically this area here is actually designed for, I think, the 35 millimeter width battery as well. So like a flat pack battery can fit right here. We even have a cover for it. Well, actually, you can kind of see it here. So you see back here, there's plastic. So these got these tie downs here. This is actually a 3D printed piece that protects the battery, because then these pokey boards are here. So this cover protects the battery, but still fits within the envelope here. You can still get access to the buzzer still has access to do that sort of thing. It uses this here. So all of these pieces are available. And then we just have a board that plugs in. And yeah, that's where we're at here. Let's talk about the most important thing, of course, which is the name. So we're going to call this new board the Loot, which I realize is not necessarily, this comes from, this is just me sitting on ChatGPT basically and looking for alchemical inspired names. But this is an old term, not like the lute like a guitar, but lute like a cover. So basically it was like they used to use it to cover pots. And so they would cover up the pots and do that sort of thing. And sorry, just seeing someone walk by there. And so they would basically cover up alchemical solutions. Alchemy is a silly thing that I enjoy finding the names for. That's where Elixir, the Aludel is a type of container. This is now the loot, the cover for the container. You can see where I'm going with this. All right, so let's first look at the 3D model. So I use FreeCAD for all of my stuff here. All I was doing here is basically just adding this little cap. This is a cap so this model is available from, this is the 1935 here from, I have their name here, but Bud Industries. And so it's really, really, really nice to have that available in here. And this is how I've been able to size up the Elixir and the Astentis and make sure we have a nice outline that matches this sort of thing. But all we did is basically, I just made a little cap for the existing standoffs here. And so we just moved the board up a little bit. And what that did is that made us flush so that basically when the test I was doing here, so if we look at this one, so all I was trying to do, a lot of camera work today, is I was trying to make it so that the bottom of the clickboard is now flush with the top of the connector. Because what that represents to me is that if I make a board that has 0.1 inch headers, 2.54 millimeter spaced headers, pin headers here, that they will also, the bottom of that board, right, basically when I have the same kind of connectors on the bottom of this shaped board, that it will sit flush. That's my assumption. And so what I had to do is that the Elixir had to move up a little bit to sit flush. And that's what I was measuring. That's some of the printing I did to test it out. And so it does seem to sit flush with the top of the board here. And so that gave me confidence that we are now at the right height for making this plug-in board. The only thing I'm not certain about is this is all showing through-hole components. I might just start with through-hole because that's a known thing. I'm not sure if I'm not actually sure if the surface mount versions of these pin headers have a different height. I assume they're the same. You know, basically the plastic, the riser height there. It could be not. I'm not sure. That's something I can do with 3D modeling, and we could do here today. But we'll find out. So let's get started on the actual project. So we know we're going to call it the loot. We have the height set by this here. I'm not going to pull this 3D model into KiCad, but I am going to pull. I basically went before the recording. I went and generated and exported the Elixir model to be a step file so that I could then re-import that into the loot project. So that's what we're going to look at here now. All right, so you're not seeing my screen. We should look at the screen. All right, let's take this guy off the cam. Let's just go here. All right, so this is the loot hardware project. What you'll notice about this is that, well, this looks shockingly similar to the Astentis, and it's because it is the Astentis. That's where we started from here. So you can see all the files here. You can go and download these at your leisure. This is these are all open source. These are the backfiring LEDs that go through the bottom of the board there. All right, and so I'm just going to go start deleting elements. There's some stuff I definitely want to keep. I want to keep the shape of the board. I want to keep the mounting holes. I don't want to keep this window here. I would like to keep these, but I'm not sure how that's all going to work because those are all, I guess those need a connection. But maybe we could get like an I2C expander or something like that to sit on the quick header, the quick connector as well, like a simplified version of the whole thing. We'll see. Might be added cost without being necessary. And then, actually, we don't even need the quick anymore because the click headers, quick and click is kind of a weird in between here. But so the quick headers, QUIC or stemma headers, have I2C and power in them, but the click headers, CLICK, also have 3 volts and I2C in them. So we're actually going to have I2C available. So maybe we could just use that without having to plug. I don't want to have an extra cable in there either, which would be nice. Then when it comes down to other things we need to add to the board that are not currently there, we need to add a cutout for this thing, this connector. And then we need to add the similar connectors here. So let's see if we can do that. So let's start ripping stuff off. So this should be good. I don't have this in a repo yet. I'll probably create a repo after the fact. Let's start with the schematic. think if we go and delete all the schematic stuff, we should be good. So I guess we get to do a little review of what's on the Astentis as well. So there's an e-ink connector. I recently learned that e-ink is actually a incorrect name because that is a that's only a certain brand. These also, the alignment resistors are also there for the e-paper, which is the proper name. These are the mounting holes. Those are going to stay there. All of this other stuff we're just going to take off here. We're not programming it. Take that off. Backlight icons we'll leave for now. Power switching, accelerometer, RPI Pico, that's gone. Also, this board is derived from the wonderful folks at P. Maroney out of the UK. Great stuff. They have a RP 2040 Badger, it's called, and that was the basis of that design. Cap touch. This is what we use as an input. So basically, we have some pads on there. These pads will also go J456. Those are custom pads that I put on the board around the edge of the connector, and then these should also go. All right. Oop, don't do that. Let's do this. Let's do this. I gotta remember what these are for. I think these are just logos, maybe. And I've started using different text. I like this better. I know that's really stupid, but KiCad 8 has, and previous have, custom fonts that look a lot nicer, I feel like, than the default font. All right. This one is user button. We'll also get rid of this. All right. So then this will be kind of the basis for that sort of thing. I also think we could potentially, put like a no-pop GPIO expander in here that we just put on the I2C bus. But that's probably a thing for another stream. What is this one? This is the Aludel lower status solder mask. Did I not put this through? Interesting. Oh, shoot. I think these are actually the icons for the, I think these are icons that might have been on the front panel. So if we look at this thing, each of these icons is actually this is a footprint as well, which I might have deleted some of these. So of course I need to go back. Let's see, just Control Z a whole bunch. Huh. See if it's cross-referencing. So if we look at the front side, what is this one? This is just a set of segments. Oh yes, I must have just imported these. So these are all just imported segments here, and I think maybe those logos went unused. Yeah, so I think I imported all those segments after the fact, and all of the deleting is fine. There we go. All right, so we're gonna delete these two. All right, and let's try updating the board. Let's see how it goes. So we're going to say delete footprints with no symbols. So anything that has now been deleted, we should see go away. Relink. Yep. Update. Now we've locked a whole bunch of stuff as well. So let's go and look at that. All right. Let's look at the back side here. This is locked. This was locked for the positioning. Yeah. So we got to override the locks. You still have all the traces. Traces are fine. Yeah, I think we're good here. Okay, so now what I'm gonna do is I'm gonna go select, right click, select filter, and I'm gonna just turn on tracks and vias. Let's get all of those. You see it highlights all of those, which is pretty cool. I see all of these resistors were also locked because those were positioning resistors for the screen that I didn't end up using, but I should have. All right, so let's go delete all these. I'm just selecting. I'm just hitting Control, selecting all these. Okay. Override locks. Let's Let's look at the front side. No, that's the back side. That's weird. I think I have highlight mode on. Yeah, there we go. All right, so these are just silkscreen elements. Delete those. This is this is just a spacing element I put on there. Actually, that I didn't end up using. I was trying to space out some of this stuff at the beginning, and I ended up moving it anyways, so let's get rid of those. This is a keep out that was defined by Raspberry Pi. This is trace from the front side. Let's delete these, delete these. There's a zone in here. This is one of the zones for the parts over there. Some space. This is some spacer stuff for the sizing up where the buttons were. And then let's. This is an edge cuts thing, so let's delete that. Hit B to redraw the zone. All right, we should, if we're lucky, see a pretty bare 3D model here. All right, look at that. All right, so we still have all of the backfiring LED stuff here. That's fine. We're going to leave that for now. Actually, I'm going to go lock all this stuff to make sure it sticks around, even if I think these should be locked. Are these locked? Oh, that's just the whole part. You got to hit the whole. Oh, these are not locked. Okay, so let's go and lock all these parts. All right, let's hit right click, locking, lock. So now if I go and try and move this part, it at least calls this out and it says, oh, you're not gonna, if you want to move it, you have a bad time here. So same thing for the zone. The zone's also locked. But we'll move this capacitor in. This one is okay to move, override locks. Just move it a little here. All right, so now we're kind of at the baseboard of this. Let's turn on the 3D render. It's rendering. I think my video rendering might be a little underpowered because of I'm live streaming this as well. The thing I like about this is it kind of shows it in more of a matte black that I expect the actual board to be in. There we go. Kind of underwhelming there. But this is basically what the logoed version of the loot board would look like. Okay, great. And this would basically be much like a cover here. So again, it's just this without this, with all this stuff here, and it would mount to the top here. Cool. All right, I turn off the 3D model or 3D render there. All right, let's close this up. So now what I want to do is I want to pull in. Oh, you're not seeing my screen. Now what I want to do is I want to pull in the 3D model for the Elixir. And then we're going to kind of size it up to how we need it here. Actually, I wonder if we could go to the Elixir, get some kind of like 3D output, or sorry, 2D output of that, and then use that to do an overlay of this here. Because we can import DXF, I believe, graphics and DXF. So we can bring in, DXF line widths. So let's quickly open up another version of this PCB new. So you can, even though I have the Loot project open right now, I can have like a side-by-side second version of this. So here's the Loot board on the left and the PCB editor of just the standalone on the right. Actually, I'm going to take this off here just because I'm going to make sure I don't show anything I shouldn't. All right, so if we go into boards, Elixir. All right, here we go. me just open up the PCB file here. I've lost the plot. Where did it go? I literally don't know where it went. This one. Aha, okay, there we go. All right, so this is actually the Elixir board. Nothing's really turned on right here, but this is the open source file you can go and look at. So I'm not going to save any of this stuff. What I really want to do is I want to go delete basically everything except these some of these components here. So let's turn on regular view. Let's turn on the export. I think we can put this to a new library. I guess we do an SVG. So we could just do the top copper, black and white. And then I think we want edge cuts as well, because then we should be able to size that to how we want it to be when we import it. Now, can we combine them? Print 1 page per layer. All right, so Elixir board SVG. So let's go look for that. Import. Goliath, Elixir. All right, so just make this full screen. So we are going to try and bring it in at once. Let's just see what happens. So it doesn't look like it's sized very well. Yeah, this doesn't look sized properly. So this brought in the entire copper layer as well. What I really want to see is I want these pads right here. So let's undo that. Let's go back over here. Let's, this is free to, I'm not going to save this, or if I do, I'm not going to use it. So let's look, this is back to the Elixir. That's what we're looking at right now. I'm going to turn on my layers so I can stop looking at certain things. Turn off footprints back. I'm going to turn down tracks, turn down vias. I'm going to turn off rat's nest. This is what I really want here. Because these 4 connectors here are all I really care about, right? For this, well, this and the outline. So let's see if we can try exporting again. Export SVG. Not mirrored. Oh, this is in mils. Let's make this millimeters. Make sure that's, shouldn't matter. I mean, as SVG is actually a unitless thing, but the problem is I don't know how to bring it back in later. Okay, so that's brought that has been exported. So now we're back here. This is the loot. I'm going to try to import now. This is the scale. This is also in mils. Let's bring back to millimeters. I think I was on a project doing some board export and everything was in mils. Export, import, graphics, continuities. I think the scale is still off. Yeah, the scale is still off there. I'm not sure what the multiple would be, because that doesn't make any sense. Even if we just overlay. Yeah. So this is closer to what I want. This still has all of the copper here. I guess because I was just turning off the visualization of it. instead of deleting it. So if I turn the objects back on, tracks, vias, and I just select here, right click, filter selection, turn these off, turn on tracks and vias. All right, so now we just have footprint copper turned on. I think there's a way I could plot just the top two layers as well. Scaling. Let's go out to an export to a DXF. Let's see how that goes. Top copper, nothing else. Edge cuts. Combine. Millimeter export. I think this is going to create two files. Yeah, so it's two files, but that's fine. Now let's try and import the DXF instead. File, import, graphics, in the Elixir folder, output, Gerber, revc. That does not look correct. This is frustrating. Applied graphics using their contours. I don't think I need to have it selected, but we can try it selected, I suppose. Plot. Let's try refilling the zones, see if that helps. Same problem. Huh. Okay, let's try going back to the SVG import and maybe try a scaling factor. Let's go hardware, board. So it looks like it's less than 1.2. But I have no, actually, no. 1.25 looks like, but this is very unscientific of me. Import graphics. Not to mention, this is not scaled properly regardless. Aha! I figured it out, folks. I'm a stupid man. These are different holes. All right. Yes. Let me show you here on the old camera. Not that helpful on my part. What I was just trying to match up was what we have on the screen on the loot board is actually these holes, and what I'm showing on the Aludel is these holes. So I think the 1-to-1 is actually correct. Damn. Okay, so then I need to figure out a way to size this properly. That's the real thing. Let's try and import 1-to-1. Graphics. So 1-to-1 is correct. It just matches the. So one thing that's interesting, I don't think I made these boards at the same time. Yeah, these were not made at the same time, unfortunately. I guess we could go based on the, well, even the scale is a little bit off there. All right, so I'm just trying to This is about right. Just looking at the curvature of the board, basically we have, so move this here. Yeah, so that's about right, but about right is not a great way to do this sort of thing. So we might need to go to the, maybe we could start here and then move to the 3D model as well, right? So we have the 3D model for the export. All right, and so these are surface mount pads here, which is fine. Let's start like this, I guess. This can be moved over a little bit more. Like I said, this is the way that I am currently doing this is not the most precise. Yeah, look at that. It's kind of like a squinting and looking, trying to make it all work. So this board outline was actually derived from the data sheet. Oh man, sorry. Yes. Thank you, Colin. Nice to know you people are here. Appreciate that. Sorry about that. Let's add this here. Sorry, I'm was going open loop there. Sorry about that. But I appreciate you being here, Colin. Okay, so yes, I was talking about the this board outline was actually created from the data sheet for this board, and it is the same between the part family. I did the thicker and thinner cases. I did check that, but this is not very precise. I'll be honest about that. So I guess one way we could check this is we could do a DXF overlay of the case itself, right? Because these mounting holes would then line up with the mounting holes of the DXF from the vendor. Actually, we can see if we can do that. Let me try and open up. I know I got the 3D model from Bud Industries. Let's see if I do CU 1935-MB. So this is the box. DigiKey carries it, Mauser carries it. But I really want to see this. This is the Bud Industries page for it. You have to register to get the 3D model from them, but then as soon as you register, here we go, 1935. Yeah, all right, DXF. I think I'm registered already. Click. Yes. All right, so let's try and get that out of here. Other thing, you can read this while I go and get that file. Just put it into the loop directory. Usually with this sort of thing too, so this is the directory that I have going on here. Usually I'll put it in something like this, like a mech folder. And this has, all the graphics that I'm using for the front panel that was from the Astentis. And so I'll just put this DXF in here as well. You see there's another Goliath icon, DXF, some of the outlines, things like that. We'll try dropping that in, see how that goes. One thing I did want to call out that I just figured out after so I've been, using KiCad a long time. In I think KiCad 5, they started switching to the .pretty, where basically all your footprints are stored in here. So these are all the footprints that I'm using for this. The KiCad mod file extension basically each is a footprint here. And one thing I always do is I always name it project.pretty, which is great. So if it was Astentis.pretty, the downside of that is that when I go and migrate a project from, so I basically took the Astentis and I renamed it to be Loot, and that worked great. It actually, there's actually a dialog. So if you do a save as at the project level in KiCad, it'll rename all your files for you, make sure they're all linked, whatever. But it's going to carry it's not going to rename your pretty folder because this is basically, this could be anything. It could be, you know, abc123.pretty. And so they just assume that you already know your name properly. And so they keep it. And so it was the stensis.pretty. And the same thing happened with the Elixir started out as the Aludel Minimax. And it got renamed, fine. But the Minimax name you can actually find in like old files throughout it. And so it's just like, because they got carried along. And today I was like, well, why don't we just rename it project.pretty? You know, like I never thought of that before. I don't know why. Yeah, I don't know. So now, but if the idea being that if you know, if loot hardware becomes, you know, loot 25 because we make the 25th incarnation of this board, project.pretty is still there. All the footprints that are hard coded to the location are still valid, and that's the key thing. So a little keycat thing. I think this will work. I don't know. We'll see. All right, so let's try opening it in here. I don't actually know what's going to happen here. I think this is going to be the entire drawing, to be honest. I'm not sure if it's going to be sized properly. As this is a US board maker, or sorry, plastics maker, you're going to, I think it might be in inches. Like I said, we'll find out. Mech, and then this. Nope, solid's not supported. Oh, that's looking okay. Nope, it's a little off. Huh. It keeps snapping too. Why is it snapping? Stop snapping. Okay, maybe it's okay. Let's see. That's pretty close, actually. Oh, right. Yes. Okay. Sorry. I keep forgetting that this is, okay. So this is a full cover for this box. Let's actually, so here's the board outline. That's where it started from. And the nice thing, I think you can break this apart. I think you can break it apart. Yeah. So you can select just this stuff. This is where this stuff came from. All right. So let's make sure we move this onto let's move it onto a different layer, because I think it was on the same layer as something else. So it looks right. So we're going to put the default inches, fine, great. Let's put this on user 1. I don't think there's anything else on user 1. Then I'm going to click into it. I think I can select all the stuff I don't want. Might not get rid of it. There we go. All right, look at that. Make some of these dimensions. Thank you, Bud Boxes, for your wonderful drawings and 3D models. Very helpful. Hopefully, I don't need these dimensions later. Oh, that's weird. Oh, this is actually from the. This is the other drawing. This is the one from. So these are all grouped together. Different layer. This one here. Let's figure out what layer this is on. I think it was on user drawings. Yes. I don't know if I can move them all wholesale to another layer. I'm just going to bring it again. Let's bring it in again. Oopsies. Let's just delete this one. Let's import graphics. Actually, I'm going to move the folder, or sorry, the same thing into the folder so that I have that drawing in there, because it's currently in the Elixir folder. So let's do that. All right, so that was this one. I'll go reset the repo. This is all, the Elixir is all under revision control, so I can go and get rid of all the, it'll tell me what projects I don't need, which is good. All right, so that's good. There's the Elixir board. I probably could have turned off the the outline in the export as well. But all right, so we're gonna move this one to user 2. And this kind of shows the benefits of having these different layers as well. So we're gonna click into here. Let's get rid of the there we go. Let's make this a better color. User 2. Not very much opacity set up there. There we go, nice bright green. User 1, also low opacity, 50% opacity. Make that a pink. There we go. Let's get this thing sized up. Okay, and now we're going to size up the dots here. So this dot needs to be over top of the, centered over the mounting point. Looks like my grid's too big. Let's go a little smaller. A little more fine control. I'm sure I could have done this better. Well, true of all my designs, but yeah, this is not, you know, I'm not like centering this. Also, it looks like maybe my mounting holes are a little bit placed poorly on the idle, that is. So maybe I eyeballed it for the, it's a little frightening, but I think I might have eyeballed it for the, it does look like it, the Elixir. So, you know, you have a little bit of slop in like how the screws are going in, and it's fine because the screws are smaller than the mounting, the hole sizes themselves. But yeah, it definitely looks like they're a little bit off. So maybe something to change in future versions. So I guess we'll have to just kind of figure it out from a bunch of different angles here. Now I'm trying to figure out, so it looks like this is right. All right, let's turn off the user 2 layer. Let's select user 1 layer. Make sure this is centered. Oh, that one has the same problem. Look at that. See, it's letting me, that's kind of nice. It's snapping that here. But yeah, it definitely is off. So, wow. So maybe we need to do a little bit of cleanup and matching here. I guess if you grab the element, so in this case the circle, I can't seem to get to that circle, but when I can, it was snapping that circle on the other one. But this is going to have to be an eyeball thing, I think, because it's definitely not, yeah, definitely not centered. Oof. Yuck. All right, things to change in the future. All right, yeah, that's, mechanical stuff is hard. Almost looks like it's rotated a little bit too. I don't know what happened on these drawings. All right, we're going to say that one's good enough. Let's turn this back on. This stuff all moves, so now we're going to move the green as well. Maybe, let's select the layer. It looks like I could have been more precise on these things. So, all right, that looks good enough for now. And now, the whole reason we were doing this is to get to these pads, right? So, save this stuff. We can turn off this layer and this layer. Now we're going to go and size up the pads to match. So how do I want to do this? First, I want to bring in the schematic symbols. So we can do that from the, if we go to schematic here. So this is the schematic for the lute. You can see it down in the bottom right here. Let's move this stuff. So what I usually do is I move this stuff kind of off, and then you can go and import from another sheet. Import, insert schematic sheet content. There we go. So from the Elixir, I can do mechanical. And you see it's like kind of redrawing everything here. Now the downside to this method is it's also pulling in any library, any like symbol library that define this. We're bringing in generic things. Really all I want is these click headers over here. But because I'm bringing the whole sheet, it probably brought in some symbol libraries as well. I think we can, so we can get rid of some of these, I think. Yeah, so we don't need this. Oh, actually some of these are the other old ones from the, this is actually from the Stentus as well. Oh, there we go. Look at that Minimax. Throwback. In fact, all of these, there's a switch on here. I don't think we'll need a switch. So let's get rid of all these. The reason to do that is that, in order to make your project portable, unfortunately, you get like kind of locked to your, to like absolute paths, and it can be really frustrating to redo all that stuff later. So there are some capabilities to do that, to have relative paths, which is always the best way to do it, I think. But I'm not the best at that, to be honest. All right. So now we have headers. Let's go into these. These are, I think, these are the SMD ones. Now the downside to this is that these are not sized as I expect them to be. We want them to be this proper spacing. So let's go look at the click standard. So there is a microbus click standard, microbus click. It's like a nice page from the Microelectronica folks. Boards, microbus, this is what we want. So this is the page, this is like the landing page. And then there is a logo, standard specifications. There we go. All I really want though is spacing. That's what usually trips me up. So these are 900 mils apart, or 0.9 inches between on center pins, right? So what we'll do is we'll basically copy this. We already have the footprints now, but then we'll make the click headers be the right spacing. All right, so, and these should actually pull in existing connectors as well. Now there are off-the-shelf click header. There's some on my cart back there, but they're actually Microbus sells a nice through hole and a surface mount actually click, kind of like a molded plastic. So it has there's a keying on there. It means you shouldn't actually be able to plug it in the wrong way. It means that it's nice labels on the side. It's very nicely made. It's very custom for what they're doing. Fortunately, the reason that we have to go a little bit non-standard here is these things are directly next to each other and they're actually offset a little bit as well. So you can kind of see it here. This is probably out of spec for what Microbus wants you to do. But you see right here, this camera is reversed from what I'm seeing. Okay, so you see right here though, those two are kind of like every other, down. And if you buy the off-the-shelf ones, which are great, they're not every other. They're just like straight out. So like this one would have all of its pins all on this side. And so then when you put two of them next to each other, they interfere like this. This is really trippy for me because my fingers are moving in opposite directions from what I expect. I'm going to see if I can mirror this. This is really getting to me. Nope, sure can't. Mirror my face, but not my webcam. Okay, so but that's the only way we could get them this close together. But we wanted them this close together. The idea is, so we did some 3D modeling when this started, because the whole idea was we needed to be able to fit them in this case side by side. And if we couldn't fit them side by side, then like kind of what's the point? What's this? This is a. I need another clipboard. It's like these things invade my life until I'm ready to do a live stream. Okay, here we go. So in my mind, this is sufficient spacing, but to get them this close, you need to use either the through-hole version, which would have been really tough for the layout here, because then you have like a bunch of holes poking through your PCB and you have to route around them. Or in this case, just having them every other, like we showed. So, but I think this. Like I said, I love this form factor. I really do. And there's like small, medium, and then large. This is the large. And so I think it's really, really great. It has enabled a lot of things for us. Even the height is okay. The height is just barely big enough here. All right. Where was I going with all that? All right. So now let's go back to the, I hit the hour mark. Classic live stream. All right, let's go back here. We're going to save. We're going to hit F8. We're going to see if it pulls these in. All right, look at that, four of those things. All right, so these are now showing on the top side of the board. They're also showing, actually I should probably switch the footprint so that they are not, these are all female pin sockets. I want these to actually be, let's do this here. Let's do it in the bomb view so we can change them all at once. So these, we're going to change. We're going to change this to be pin header, pine header, 01 by 08, vertical, surface mount, single row. That's the wrong pitch. 2.54. Boy, I'm really bonking on this one. Underscore P, 2.54. Vertical. All right, now the trickiest part in all of KiCad is it the pin 1 left or pin 1 right? I believe it's right. Yeah, this other one is right. Let me tell you, it is very frustrating to design a board with a bunch of these on it, and then they show up and you're basically like, it manifests as like an off by 1 error. It's very frustrating. I don't even know anyone who makes pin 1 left. So maybe in Australia. All right. I think if I hit F8 right now, it should update these, but we should see nothing other than this should say male. And then, and this looks pin 1 right. So that does show. And then the 3D model will also change. And that's what I really want to see. All right, here we go. Update. No, the did not change for male because it kept the, I don't think actually the nomenclature is even male, female anymore. It's because that's the value that's here. All right, just like that. Update, F8, update, close. Let's look at the 3D model, see how it looks. There we go. So a bunch of pins, cool. That is what I was hoping for, great. So let's flip on the other side. So really, I'd like to keep, top side top, bottom side bottom, right? In this case, if we have the logos on there, I expect that to be the top. I expect the pins to be on the bottom. And so let's try and flip them on the other side. So we're going to select all these. Oh, that's what I was going to do first. All right, so first, I'm going to switch to inches. I'm going to switch the grid to inches. Switch to 0.1. I'm going to align these to the grid now. And what I really want to do is I want to make, I got to make sure I've got the right parts here. So J1 goes with J7, because of course it should. and J2 with J8. There's a legacy thing for you. All right, and so, that I'm going to move this footprint. All right, so that should be on 0.1 inch dots right now. Basically, the grid is 0.1 inch, and you can kind of see. So if you watch down here, this is showing the absolute. So this is basically this is currently at 4. That's actually showing my mouse wherever it is. And so if I hit the space bar, you can actually look at, then this sets to 0. And this is the DX, DY. And I find this to be one of the most useful things in KiCad personally. It really is CAD, it's not just KiCad. So they set that to 0, and now I can just mouse over here, and I know that this is now 0.9 inches away, right? So now if I go in, and I want to, what you see there is I just grab the pin. I want to grab actually the footprint, which will be the center of the footprint. So there we go, jump to the center. And I want this to be at the 0.9 inch mark. Okay, so now the center of J7 is 0.9 inches away from the center of J1. Now what I'm going to do is I'm going to group these together. Grouping, group. So now we've effectively made a, man, I did not do that properly though. I effectively made a microbus header. However, key trap here, I think this is actually from how I drew this. So I drew this to match, but you see pin 1 and pin 8. So basically, you need to make sure that this rotates. So let's ungroup them real quick. Rotate this one around the axis. And then, so again, this is going to come back to the, so this is how I expect it to look. But because, yeah, 1, 2, 3, 4, 5, 6, 7, 8. And these are, so really this is one of the things that I struggle with. I think there's a way to do this in KiCad better than how I do it. This is 2 discrete parts, right? I'm actually ordering 2 parts on DigiKey or Mouse or whatever. And I want the, if I had these boards assembled, I want to have J1 and J7. However, I want them to act. I would love to have 1, 2, 3, 4, 5, 6, 7, 8, 9 through 16, right? I want that to really be how it looks here. I don't personally know how to do that, but I want to have still 2 discrete, like purchasable items. But I want the representation of this to be one contiguous thing, especially because I don't have to do this every time. I don't want to mess this up again. Yes, I have messed it up before. So and this represents, so analog, the analog pin in the upper left corner is correct. PWM upper right corner is correct. We can verify that on here, right? And so you see ground, but really how I almost always visualize a microbus header here, ground. All right. So let's make sure those are right. Go back to here. So just checking one more time. Mouse over, hit the space bar. I'm at 0. All right, there we go. 0.9 inches away with no XY. So now I'm going to group these together. I'm going to group this off to the side. And then I want to do the same thing here. Analog up in the left corner, ground in the lower right corner. All right, let's now move. Just put this on center. And move. Oh, actually, that's as I'm moving this on center. Nope, that's a pad. So you can grab the pad or you can grab the footprint. I want to make sure I grab the footprint because it actually has a center mark, like a centroid, which is also what the a manufacturer would do. All right, I'm going to place it here. Click 0 to capture that center, and now I have a 0. I zeroed it out again. Grab J8. That's not grabbed in the right spot. There we go. There's a center, and now I want to make sure I'm at 0.9 inches away. Yep, that and that. There we go. So now, if I group these as well. Group. Okay, so now these 2 items should move in concert, even if I move it back to millimeters, which is kind of how I natively want to do this stuff, right? I could have done all that same stuff with, I could have done the same thing with, in millimeters, 2.5 what is it, 22.86 millimeters, but I think it's better to be a little more precise here. Okay, so I expect these to go somewhere around here. These to go somewhere around here. I'm going to change my grid. I'm running out of time. My phone was just telling me. Back in millimeters, I'm at 0.1 millimeter grid, but these are still, because these are grouped together, they're still moving 0.9 inches away from one another. All right, let's turn this back on. Actually, this is not correct yet. Just first thing I have to do, flip. I have to flip these. All right. And then, there we go. Let's turn on user 2. Ooh, oh, that's hard to see. And then let's match them up. Why is this not showing properly? Okay, so I'm showing the top side. I exported the top copper layer, which is basically this one. So I exported the top copper layer of this one. Zooming, trying to zoom. All right, so this is the top copper layer that I tried to export. And now I'm trying to visualize the bottom copper on top of it. I think this is actually right because the part that I'm using is, I think that's right actually. Because, what is this trying to grab onto? That's weird. Although the pad sizes are different too. That's odd. So what I'm really trying to get is the centers, right? The center line of the bottom one. I think this is because the part is flipped over and it has the every other. But I'm not sure. Let's see what this looks like if I just do this. Oh, wow, that is a busy diagram. I'm not sure why these copper pads are showing as smaller on the Elixir board. That's a little concerning. It's because that's why. It's because they're pin headers instead of, and they're narrower than basically male versus female. Huh. All right, that didn't work out as great as I hoped, if I'm being honest. Like I said, we're just kind of eyeballing the distances now. All right, let's take a look at what it looks like. So this looks like I expect it to. And these are sized properly. So I think we're on a good path, but I think I'm going to save this for the next time because I am very much out of time. And I appreciate all of you sticking around with me. So this is the start of the loot form factor. I think the other way I'm going to check this in a future stream is to just export this whole thing as a step file, plug it in FreeCAD on top. I guess we'll be able to visualize there as well. So some of the things we learned today, one, mounting holes that plug into different parts of the board are in different locations. Male and female headers are different. Basically, yeah, you get to watch all of my mistakes in real time. Would I have ever shown this if this was an edited video instead of live stream? Probably not, but that's okay. All right, so in future streams, assuming we come back to this and I don't go and do all this work on my own, which has happened before, in future streams, what I would expect is that we would add a GPIO expander. we would start adding some power layers here. Like, so this has 3 and 5 volts on it. So maybe we want to dump that into a layer, or maybe we want to just, use it ad hoc based on each design that's plugging in here. And then what I'd like to do for the first loop is the type of board this is. For the first loop board that we're doing, I'd like to just add a bunch of relays and terminal blocks. That's really what's been in my head the whole time. That's going to be a bunch of like terminal blocks are almost always through hole, just because they're like beefy and need to be plugged in well. And so seeing how that all aligns, seeing how many parts we can fit on the board. Oh, I still need to do the cutout. Sorry, I forgot about that too. Let's see if that is on. Is that on here? So I might want to do one more overlay layer of just the silk screen on the here. So we don't have the silk screen for this specific part, but that would be really useful as well, because that ultimately is going to be a cutout we need to do for the loop board as well. So that'll probably be in a future stream. All right. Well, thank you all for showing up. Thank you for watching after the fact, if you're watching after the fact. And yeah, we'll be back in future streams. And check out the Goliath YouTube channel for more content, shorter form content than this, and our blog, blog.goliath.io. If you want to see explanations of this stuff, I owe everyone a write-up of the DRAM boards that we've been working on. And hopefully some more news about that soon.